Alright, today we are going to take a look at how to simplify writing ionic compounds using what we call the crisscross method. This will allow you to write the chemical formulas for ionic compounds without needing to draw the Lewis dot structures or the Bohr models of the atoms. So the first thing that we need to be able to do is identify the charges of each atom that we want to use in our ionic compounds, and we can do that using the periodic table. So the group an element is in is used to determine the charge on most atoms. You can see that it doesn't cover every group on the periodic table, but a vast majority. So on your periodic table in the back of your notebook, go ahead and label your columns as shown here in yellow. So column 1A is a 1+ charge because those atoms lose one valence electron. Column 2A is a 2+ charge because they can lose 2 valence electrons. We're going to skip over the transition metals in the middle. For now, we will visit those in a few days and find out what's different about them. Group 3A is a 3+ charge. They lose 3 electrons. We're going to skip over column 4 as well because carbon is a nonmetal and silicon and germanium are metalloids, and the bottom are metals, so there's just too many variables in this column to label it as one thing. But we will still use some of these elements and we'll have some different methods for them. For the next column, column 5 has a 3- charge, so it has 5 valence electrons and wants to add 3 more to get to 8. Column 6 has a 2- charge because it has 6 valence electrons and adds 2 more to get 8. Column 7 has a 1- charge because it wants to add 1 valence electron to get to 8. And the last column is 0, it does not have a charge. So for today's practice and our first practice set after this, we're going to only be using the columns that are labeled on here to find our elements in. So it narrows things down a bit for you. Alright, we're going to take a look at some examples of some ions and the compounds that are made from them. So it says, what do you notice about these ions and the formulas they create? So take a second and look at them and see if you find any patterns. Alright, so something you might have noticed is that our first 3 compounds all have sodium, Na, and on the left side we have sodium written as a positive charge, 1+. And let's take a look at that first compound. It's combined with chlorine with a 1- charge. You can always look back in your notebook to page 105. This was the compound that we looked at already. And we can see that it creates NaCl, 1 sodium and 1 chlorine. When we look at the next one, sodium still has that 1+ charge, and it's paired with sulfur with a 2- charge. When the compound is written, we get Na2S. What that means is that there are 2 sodium Nas and 1 sulfur S in the compound. Our third one, we still have sodium and it's paired with phosphorus with a 3- charge, and we end up with Na3P. So there's kind of some pattern forming here with our charge and our number of sodium that we are using. The last one has magnesium with a 2+ charge and phosphorus with a 3- charge. And then it's written as Mg3P2, meaning it takes 3 magnesium and 2 phosphorus to make this compound. So you might notice that the number with the charge on the magnesium and phosphorus switch and become the numbers at the bottom, or subscripts, on the compound. So we're going to use that idea to help us figure these out and how to write their compounds. Something else you might notice is that all the positively charged chemicals are on the left side of the compound, and all the negatively charged ones, or the anions, are on the right side of the compound. That's very important, and that's a pattern we're always going to use. It's convenient too on the periodic table because all of our positive ions are on the left side of the periodic table, and our negative ions are on the right side of our periodic table. So it follows the same pattern. So let's take a look at how these compounds are actually formed from their ions. So first we're going to take a look at an example with sodium and oxygen. So an element with our positive charge, or we call it our cation, is always written first. So we write sodium with a 1+ charge. We get its charge from its group on the periodic table. And then our element with our negative charge, or our anion, is always written second. So we have oxygen with a 2- charge, and again, we get that charge from its group on the periodic table that you've already written. Now, to write the formula, we use subscripts, or small numbers, to the lower right of the chemical symbol, the element symbol, to represent the number of that element present in the compound. We can see down below, Na, or sodium, has a 2 after it. That means that there are 2 sodium atoms in the compound. The subscript of 1 is never written in a chemical formula. So we know there is a 1, there's 1 of that chemical when that symbol is written. So you'll see there's an oxygen written with no number after it. As long as the O is there, that oxygen, it tells us there's at least 1 oxygen. If there were more than 1, then we'd see that number written down below. So this compound has 2 sodium and 1 oxygen atoms. So how do we get from our chemicals with their charges to the chemical formula? We use what's called the crisscross method. So the easiest way to think of writing a chemical formula is to use the charge without the plus or minus of one element as the subscript of the opposite or other element. So down below we have calcium with a 2+ charge from the periodic table, and chlorine with a 1- charge from the periodic table. We are going to take that calcium and chlorine and crisscross the numbers without their charges. So the 2 from calcium is going to become the subscript on chlorine, and the 1 from chlorine is going to become the subscript on calcium. We don't write the 1 with the calcium though, because as long as the Ca is there, we know there's at least 1. Once we do that, we can see that the charge, the plus and minus, are no longer there, and we only have the numbers at the bottom. So if we were to look at this, it says CaCl2. That means we have 1 calcium, Ca, and 2 chlorines, Cls, in our chemical formula. So how do we know if we have written our formula correctly? How can we check it? To check our work, we can always write out each of the ions and make sure that our charges add up to 0. So our compound we made from crisscrossing the charges is CaCl2. If I was to break this down, I would have 1 calcium with its 2+ charge, and I would have 2 chlorines. They each get a 1- charge, and we get all of those charges from the periodic table. We can see that having 2 positive and 2 negative charges adds up to 0 and makes a neutral compound. And that is always our goal, is to make it neutral. So this is a way of checking your work and making sure that you have written a formula correctly. Let's take a look at another example. If we were to put aluminum and sulfur together into our compound, let's figure out how it would look. The first thing we want to do is write down our symbol for each element. On our periodic table, we can find that aluminum is Al and sulfur is S. Remember, it's very important to keep track of if the letters are capital or small. Our first letter is always capital, our second letter is always lowercase. Next, we want to find the charge of those elements from their column on the periodic table. So we labeled that up at the top. Aluminum has a 3+ charge, and sulfur has a 2- charge. Now that we've written the symbols with their charges for each element, we are going to crisscross the charges. So we're going to take the number from each charge and make it the subscript on the bottom of the element opposite of it. So the 3 comes down to the subscript on sulfur, and the 2 comes down to the subscript on aluminum. Now we can write our final formula, Al2S3. What this means is that our chemical compound has 2 aluminum ions, and 3 sulfur ions. If we think about this, having 2 aluminum would give us 2 atoms with a 3+ charge. That is a total of 6+. 3 sulfur would mean 3 ions each with a 2- charge. That would give us a total of 6-. So our positive and negative charge balances out and would equal 0. Alright, now is your opportunity to try some other substances. We've got 3 listed here. First one is aluminum and oxygen. Number 2 is lithium and nitrogen. Number 3 is magnesium and sulfur. Pause the video for a bit, try these out, and when you're ready, press play to find out the answers. And down below there is a note. It says reduce subscripts in ionic bonding when possible. The correct formula is always the lowest ratio of atoms. What this means, and there will be one of these 3 that is like this, is that if you have subscripts, once you've crisscrossed, that can be reduced, we always want to reduce them to make them the lowest whole number ratio we can. So as an example, if one of your subscripts is 4 and one of them is 2, we can reduce that to 2 and 1. Alright, pause and try these out. Alright, let's take a look at the answers to your practice. So aluminum and oxygen. Aluminum is a 3+ charge, oxygen is a 2-. We should end up with Al2O3 when we crisscross. Lithium is a 1+ charge, nitrogen is a 3- charge, and we should end up with Li3N after crisscrossing. And our magnesium and sulfur. Magnesium is a 2+ charge, sulfur is a 2- charge. If we crisscross those, we get Mg2S2. We can see that they're both subscripts of 2, which can be reduced to 1 and 1. So we can write MgS. So this is the end of our notes. You're going to try the crisscross practice in class now and work through some more examples of this. Be careful when you're writing your chemicals to really be sure that you're showing the upper and lower case letters and that your charges are written as a exponent and that your final formulas, their numbers, are written as numbers at the bottom, a subscript, okay? It needs to be obvious that those numbers are going from the top to the bottom of the chemical formulas. It is really important what corner and things the numbers are in because they mean different things in chemistry. So if you have crazy handwriting and sometimes it's hard to tell where you're writing things, you need to slow down and be very meticulous about this and make sure they're written correctly. You will not get the points on a test or on your practice if they are not written correctly. Okay, so be careful, take your time. Thanks.